This is the Edge Working Group meeting of October 16. On the meeting, we have Idong from Huawei, Sarab from Intel, and Ofer from Qualcomm. Okay. So I wasn't attending the previous meeting, but as I understand, you wanted what Milan suggested that need to be done is to look at the statement of work, because the deliveries and the timeline that we have been discussing apparently is not going to happen. Hello, good morning.
Hi, good morning. This is Manish from Microsoft.
Hi, Manash. Good morning.
Hey, how are you?
I'm good. Thank you. So I was just saying that on the previous meeting, I think the agenda that Milan set to this meeting was the need to review the statement of work, because the current statement of work, we're already sleeping in terms of deliveries and timelines, so we should probably review that. Any other agenda items?
No, I think that was the one we agreed that we would review and revise, right?
Right. Saurabh, Yedong.
Yeah, okay with me.
Yep, works.
Okay, so I'll share the current statement of work. Okay. So the main statement of work talked about describing profiles. Basically, the statement of work of the working group was to identify, to classify what we mean by edge and to create profiles. And right now I'm showing the part that talks about deliveries, and there's under it there is goals and milestones. So in the deliveries, we said that we want to have a document that describes the edge. What does the scope of edge means? This is delivery number one. Delivery number two was to define edge profile. And then delivery number three was to define a few profiles that will be covered, like to look at a mobile phone, to look at a smart device, maybe IP camera and things like that. Delivery number four was to collaborate with quantization working group to define things related to edge, because we said that quantization is important for edge. And delivery number five was to collaborate with the modern zoo and operator SIGs. So I think, first of all, I think that there is no quantization working group, if I'm not mistaken. Right?
There used to be one, but not anymore.
Yeah.
I think most of the work is covered now in the operator or the converter SIG.
Okay, so the first update that we need to do to the SOW is to remove delivery number four. Delivery four. And I think the same, there is no modern zoo. So who owns the modern zoo development these days?
There is a model zoo. I think it's part of the core working group.
Okay, so there is still a... Let's see for a second. ONNX. So I'm looking at ONNX SIGs and I see only converters, infra, and operators. Maybe there was intention to do a zoo.
Oh, if your question is if there is a working group for the zoo, there isn't a separate working group for the zoo.
I'm looking right now, I'm sharing the document that talks about the ONNX governance, and it does mention that there is going to be a SIG for the modern zoo and tutorials, but I don't think that this SIG was ever created or is having meetings.
Right, that's correct.
Okay. So getting back to our statement of work. So delivery number 4 was collaborate with quantization working groups. So each probably needs to be operators. And to collaborate with the modern zoo SIG, there isn't one yet, I guess. So in terms of milestones, we said that we're going to finish document number 3 in Q3 of 2019. Document number 3 was the defining of specific profiles. So we're definitely off track here. We need to set new goals to define profiles. And I think the real issue here is that we probably don't have enough people attending so that they would be able to take upon themselves to define profiles. So the question here is, do we believe that the people who are attending now are able to take upon themselves, each one to create a profile and deliver it, let's say within, if we move the timeline to shift it into Q4 of 2019? Or maybe even, let me try and ask it differently. Do we believe that we need to go back and even visit the definition of edge profiling as it was defined in number 2? Because I'm not sure that we actually finished that.
I actually, want us to talk about number 2 to really understand what would be the end goal of the edge profile.
So the original end goal of a profile was to be able to generate a compliance package so that we can go and test devices based on their compliance package, and let's say the ONNX project would be able to publish in a way the ONNX project would be able to publish these profiles and then have vendors pick up the test packages, pass these tests on their devices, and then they would be able to say that these devices are compliant to a set of profiles. And then the user knows that if he has a certain model that fits into the characteristics of the profile, he knows that the device can run it. And in my view, the most important part is, first of all, the set of operators that is supported by the device. Operators and data types, if we're talking about quantization. Because right now, there is no clear mechanism for devices to define that they support a subset of operators and which operators exist in this subset. So instead of going and trying to map each operator separately, we are grouping the operators to say, this is the group of operators that a device that is processing video on the edge should be able to support. One of the things that Saurabh from Intel suggested was that these profiles can also be used to set execution mode. If you have a device that supports a wide range of profiles, let's say this device says that it's able to support mid-high profiles of video classification, then there will be an API, which is right now outside the scope of this working group, that would allow at runtime to set the execution mode for a specific model. So it's extending the original meaning of profile. And I think that one of the things that we mentioned, you can still hear me, right, Manash?
Yes, so far,
Yeah.
I can hear you.
Okay. So I think, Manash, one of the things that we talked on over the workshop is defining a mechanism to query which profiles are supported by a device. So all of it can go, like, the original scope of the working group was to describe profiles because this is the starting point. From this definition of profiles, now we can have an API that queries profiles, and now we can have an API that sets a profile for a specific model for execution. But unless we describe the grouping into profiles, the subsequent activities cannot happen.
Right. My rationale for asking for that query was because there is, there are ops and there are data types, and the combination of that becomes quite wide. So as the device evolves or the spec evolves and the device firmware evolves, there is opportunity for the two to not stay in sync. So the latest spec and the data types and changes may not be all supported in the device firmware. So having the ability to identify which specific profile the device supports will provide consistency for a model to be executed, or a graph or an op to be executed on that node versus executing it only on the CPU in software.
Yeah, I agree. And this was also, to the same point, this is an issue of interoperability. If you're trying to distribute on different devices the same model and you want to know that this model works, so the basic building block of the model, which is the operators inside, you have to know that these operators are supported by this device. And this is what a profile provides, in a sense.
So, Manash, who do you think would be serving the API that you mentioned? Like, is it a runtime? Like ONNX as a standard, how would that be able to specify this API?
So the runtime could make use of that API or have some way to query for a profile and map it to what the spec says. A profile could be a subset of the ops that based on what we decide. And that would then enable the runtime or any runtime to identify the specific set of ops that the underlying hardware is going to support.
So now the question becomes, what do we put as part of the, what do we put as part of the working group statement of work? Because initially the statement of work was just the profiles and not talking about any subsequent APIs that use the profiles. We said this can come as another working group. And
or that can be an implementation detail, right? Of how you, or would the spec define the API as well?
I agree. It can be. This is why it's a good idea to separate between the two. Profiles are profiles, and they are something that is part of the ONNX specification. And the way that you use profiles, ONNX can standardize one way. For example, if you look at ONNXify, that can be one way, but it's the same way that the ONNX file format is not dependent on the ONNXify API. ONNX profiles shouldn't be dependent on the API that uses them. That's my opinion. So in terms of statement of work, I just want to see that we all agree that we keep it, for now, we keep it only on around defining the profiles. The way that you use them is in another working group, like a subsequent working group of this working group.
I think what I would like to better understand is how these static profiles would apply on a scalable computing device. I fully agree with you that the need of profiles for fixed function hardware like security cameras or smart speakers. How would we apply and make it relevant for scalable computing devices like personal computers, which in the current definition of the edge device is still describing it, right? How would we make it relevant for those?
I envision that like a device may support multiple profiles. So is that what you meant, Saurabh, that when you say scalable, that it's not a fixed function device, but multifunction device?
Yeah, so it's a relative thing, right? So I can say that a PC can support profile X in condition Y, and then the condition changes, right? You have many apps running simultaneously. A lot of things are going on in that environment. And by the time I am done saying that I support this profile, maybe now I don't support that profile anymore. And that's why probably, in my opinion, we probably need some form of a profile which is dynamic also. And having the runtime better understand, this is what are the needs of the model. So it doesn't just out of the box fail. Let's say my model requires, let's say my model requires 500 MB of memory and I only have 25 MB left. At least I would know that I cannot run this model. Let me gracefully exit. rather than me attempting it and then failing it.
So that can happen in one of two ways. Either a profile is part of the model description, which means in the container, in the protobuf of the model, we give a suggestion to extend it. So there will be an optional thing describing the profile, like the lowest minimum profile required to run this model. That would be one way. And the other way is by an accompanying API. When you load the model, you also describe to the runtime what's the minimum profile required. And then the runtime can say yes or no. But I think, again, we need to decide what we are defining, what forms into definition, which is part of the ONNX specification and what's not. And if we define an API, the problem with defining an API is that you're actually forcing people who want to use this capability to do it in one specific way. While so far ONNX is being able to be used by multiple vendors in multiple different ways, because it doesn't forces you to one API. It forces you to, it describes how the container looks like, but loading and using this container is outside of the ONNX project definition, and everybody are welcome to do what they want.
So, so ONNX is a format, right?
Mm-hmm.
So it's a format of representing that graph. So are we saying that a specific graph would fit into one or many profiles? Or are we saying the ops that are contained in the graph would fit into a profile, one or many? The reason I ask this is, if we make the profile data part of the ONNX model, the protobuf, that means the converters will have to be aware of this notion of profiles and be able to identify which specific profile the model belongs to.
So the way
Right,
that we
and which in
describe
turn,
sorry, go ahead.
no, go ahead. I think you get my point.
Yes, I think so. And when we describe the profile, this goes to the document that described the profile. It was not only this set of operators, it was also a few characteristics or attributes. And one of them is the amount of, let's see how we described it nicely. So we gave 5 different vectors or attributes: accuracy, size, latency, and power consumption, and data locality. So size is also talking about what's the size that this neural network needs in order to run. So it's not only the size of the weights, but it's also the size of the activations. So this thing is beyond operators. It's looking at what's the memory consumption that executing this network requires, because this is another parameter in knowing if you can run the network. So to your question, if saying one of the ways that I mentioned earlier was to come with a suggestion to extend the basic proto, to have an optional field which describes the profile. And it's optional. You don't have to do that. So converters, for example, any converter would be able to just convert the model without adding a profile, and someone can come later on and edit the container and add a profile information into it. So even if we do this suggestion and we extend the container to be possibly aware of what's the profile, it wouldn't be a mandatory thing. I don't think it would be a good idea to put it as mandatory. It will probably create a lot of resistance from people who are trying to create converters, because as you said, if you put it there and converters would have to fill it, then now converters would have to be aware of the different profiles. So we want to put it as an optional thing and not as a mandatory thing. Did I make myself clear, or like?
Yeah, I understand. Yeah, so that may be a good approach. I think we can look into that.
And I'm saying that it's not the only way. We can say that profiles are not added into the container, and there is a side channel that implementation needs to provide profile information. So it's not part of the container definition. I think both options are on the table, and to me, it's kind of a second level of details after we describe what's inside the profiles and after we take and we create profiles. Now, Sarah, about that point of static versus dynamic, I think we discussed that in the past, and let's say if we encode the profile as part of the container. Okay, let's say that we go with this proposal that says that we extended the ONNX container so that the proto has a profile definition. So it would contain the set of profiles that this model supports. So you can say this thing is not a single value, but it's a multiple value thing that you can say, or if you remember, we try to partition each profile to say there's a low, mid, and high. So you can always try to run it in each one of these levels.
Right. But there would be some description. So low, medium, and high are just adjectives, right? Describing like some specific numbers, right? At some shape and form, there would be some place, like there would be a definition of what is meant by accuracy for low, or size for low, or latency for high, right?
Yes.
Yep.
And the idea is, if we talk about the terms that you mentioned, so these are the static profiles, and at runtime you can select to run the model in each one of them. Now, I think what you described as a dynamic profile is the ability, instead of a set of discrete values, to kind of have a continuous scale of possible, let's say, I want lower latency, so to be able to specify exactly what's the latency that you want, or to be able to specify what's the accuracy that you want. And based on that, the runtime can execute or not. And I think, again, it's diverging from the original meaning of the profile that was all around compliance and making sure that things can run. And the idea was, let's say, if you choose a set of discrete definite sets, you may end up with something like just throwing a number, 20 profiles or 30 profiles. If you start saying that each one of these vectors can be described separately by a number or something like that, now you just extended the possible range of profiles to be much, much larger. Which is possible at runtime, but for compliance purposes, it doesn't help to sort out compliance of devices.
So even for compliance, wouldn't we be able to use those discrete numbers to make sure the underlying device is compliant to be able to run that model or that run in that particular mode? Like there is a way we can qualify static profiles on a device. Same way we could say these are dynamic profiles and these are the values that it has, and let's see if that device can meet the minimum criteria. An example could be maybe accuracy, right? If we say that for a particular profile, it requires this accuracy, and then that basically will describe the ops and the data types, correct?
It would describe data types and execution. A set of operators is driven from a set of models that we kind of target this profile to support. But yeah, I agree with you that during compliance, you want to test a set of profiles which are static and discrete in their attributes. Once you passed this compliance, then you come into execution, and at execution time, maybe it's possible for you to describe that you want higher accuracy than required by the profile, but that should come as some sideband information as part of an API. So
I probably have just trouble getting my head around the sideband API. How would we manage it? And
I don't know if we want to manage it. Right now, we don't. The ONNX is not managing how applications are loading ONNX. Each one has their own way. ONNX runtime has one way to load ONNX, GNU another way. Qualcomm Snappy has another way to process ONNX. So the way that a model is loaded and executed is not governed by the ONNX project. The only thing that is governed, actually there's two things. One thing which is governed by ONNX is the container and everything, all of the tools around the container, converters, validation, all of these things. And the other thing is the modern zoo of models which are compliant to known networks and are kind of approved or ratified by the ONNX project. The way that you process ONNX is not part of the project. This is at least my understanding. There was an attempt to standardize an API. It's called ONNXify. Some implementations use it, some don't. We can do the same, we can, as a subsequent working group, we can define an API that uses the profiles, queries the profiles, able to set attributes based on the attributes of the profile to try and meet lower latency, or higher accuracy. But that would be only kind of an example code or recommendation. We wouldn't say to people that this is the only way to use profiles. Just like ONNX project doesn't say to people that ONNXify is the only way to load ONNX.
Makes sense. Makes sense.
Okay, so
I thought the compliance part is like more an implementation thing, but I think as long as the container has the ability to describe these 5 or 6 KPIs, I think that should cover the needs of scalable computing devices.
So I think including that profile in the container is looking at the problem from the top down. That is, a model defines the profiles it attaches to. Should we also think about how the hardware or the device is going to comply with the set profiles? And should there be a similar set of profiles or exactly the same profile that the hardware is going to attach to and say it is capable of executing profile X? Because that profile X is about certain ops and certain data types, and it has the kernels implemented for that.
I think our intention was actually starting from the hardware, in a sense. Starting from saying that these profiles describe what the hardware is compliant to. And I think that your question is more around how does someone knows which profiles are supported by specific hardware? How can we make it happen?
The how is one thing, but today we do not even, I think there's a gap that we do not have a defined subset of ops that a hardware is optimized to, right? And that can be, that I could put a finger on and say, okay, once the hardware is compliant to this profile, I know the kind of models it will be able to run, or the kind of the nature or the characteristics of the hardware.
I agree. This is supposed to be part of the profile definition. What is the set of operators which is supported? So
okay,
let's
so
say,
then, I guess.
So I'm just saying, let's say that you have a mechanism. Later on, we try to find out what is mechanism. But let's say that you have a mechanism that if your implementation, if your firmware, if your framework is talking with device X, some type of a CPU, you can know which profiles this CPU supports. It can happen in one of two ways. Either there is some list on a website, on ONNX website, that says these types of hardware are matching to these type of profiles, and then vendors need to look at this list and use it, update it and use it. And another way is to have some query mechanism.
Yeah, I like the query mechanism. I think is going to be an option or a choice the runtime can make. But the idea then is that the hardware has a well-defined boundary, right? They can choose to be optimized for a set of profiles, and that then becomes a well-defined criteria for compliance testing. It is a good criteria for graph partitioning. It can become, there are a lot of downstream benefits for that information to be encapsulated in a profile, and if and that someone can go query.
Yes, I agree. And this is all comes down to seeing that we can do a profile definition, which is giving all of these. This is the exercise that we started to do, and I think that we kind of got stuck on the way, and we're not making progress on finishing this exercise. This is exactly what we wanted to say. We wanted to say, okay, what's inside the profile? So we created a document that describes what's inside the profile definition, and then the next step was to try and create a template or an example of a profile, and to see that everybody are good with this definition of a profile, and then go and start creating more of these. That was supposed to happen. We were already supposed to be after this point. And so far we haven't got there because people just didn't have time to invest in it. So now we need to update our statement of work. So maybe what I suggest to do is to try and kick it back into action and to come up with an example of a profile definition. So the question is do we have someone that is volunteering to come up with such a definition? To take, I don't know, the example that I always think about is something like an IP camera or smart speaker as two examples of devices that need to be well defined, and to try to create profiles for this.
I agree with you. I think we may just then focus on defining the set of profiles and go around and review if that's sufficient, something is missing, or it's too excessive.
So there was a proposal that we created on the we showed on the previous workshop. I'm just trying to find this proposal. Okay. So So initially, when we talked about profiles, we thought about describing a functionality of a device. For example, it's a smart speaker or it's an IP camera. And then say, maybe there's a device that wants to be both a smart speaker and camera, so he supports these two profiles. But then we came into kind of a realization that these definitions are not good because in a sense, what happens, it creates too much combinations, basically. It doesn't really captures. The edge devices are not that clear cut of functionalities. So an alternative proposal that we said was to come up with a set of profiles which is based on type of input. We can call it a sensor, for example. And then inside it to describe different nevens. And the third way to try and map the domain of profiles is to think of more in the orientation of machine learning, classification, segmentation, NLP, attention systems, to try and classify and say this device knows to do basic classification or basic segmentation. So these are three separated ways to come up with a set. So I think the question is which one of these ways we're trying to go, and because I agree that it would be good to have an initial list of which profiles we want to describe, but that requires deciding on the approach. Do we base it on input kind of thing, or do we base it on machine learning type, or maybe there's another way to try and capture the set of profiles?
Yeah, I think that's an interesting question because both would have trade-offs. So what do you think? Should we go with the machine learning approach? Would that like help on the implementation detail for a device maker?
I don't know. It's a good question. But I think that the proposal to first of all try to describe a list of profiles before going and attacking kind of each profile separately is a good thing. So maybe we should just come up with different suggestions to describe set of profiles. And maybe I've been thinking there is a foundation working group. I'm sure that you're familiar with, you heard about it, that they were doing a survey. So they were asking, they went and published on all of the GitHub channels that there was a survey, and companies thinked out their options. So maybe this is something that we want to do as well. Maybe come up with kind of a white paper describing the different ways to describe profiles and put it out to a survey for people to see what people prefer. The foundation working group got 25 companies answering on the survey. I would be happy if we get 10 to answer.
I think we should use that idea.
Okay, so maybe as an action item, I can start creating this white paper, circulate it first between us that talks about the different ways to describe profile sets, and then we send it out to all of the different, publish it in all of the different GitHub channels for people to do the survey. Okay, sounds good. So one thing about the statement of work, I want to go back for a second to the statement of work, if you allow me, because I do want to see that we are coming to some conclusion about the changes to the statement of work. So just to clarify what we said, we are saying that document number 4 about collaboration with quantization working group is not relevant anymore because it needs to be the operator SIG. And about the milestones, so right now, maybe we can create a new milestone for 2019 Q4 to finalize a set of the list of profiles. And then we can say that we can start describing each one of the profiles.
So over on the line number 3 here,
Mm-hmm.
we're still talking specific profiles, right? What is our final scope of work? Are we going to be able to cover dynamic or not? And if you look at number 3 there.
Number.
Yeah, right here. It says
Yes, you're
profile.
absolutely correct. We need to modify that.
Okay.
You're correct. So the modification would be I think I need to see if it's.
Hey, gentlemen, I have to drop off. I have to run to another call. Ofer, thanks for driving this. I will look forward to reviewing that SOW again offline.
Sounds good. So we need to also do statement of work changes, just like Saab described, because it's no longer one profile per device. I agree. So let me go over the statement of work and try to clean it out and see if there's some places that we do a one-to-one mapping, because this one-to-one is no longer correct. Okay. Great.
Thanks, everyone. Have a nice day.
Sure.
Thank you. So we'll meet on in 2 weeks from now.
Yeah. Ofer, do you need any help in the meantime on dynamic profiles?
No, not for now. Thank you.